Hello students, welcome back to Husky Math. Today we will learn about Rolle's theorem and Lagrange's mean value theorem in one video. So I have already written the statement of Rolle's theorem here. So Rolle's theorem states that if f is a real valued function such that fx is continuous on closed interval a comma b, fx is differentiable on open interval a comma b, and fa is equal to fb, then by Rolle's theorem there should exist a real number c between a and b such that f dash of c will be equal to 0. So in order to apply Rolle's theorem, these three conditions should be fulfilled. Only that time we can apply Rolle's theorem. Now let us look it graphically and try to understand. So here's my 2 points on x-axis, that is x equals to a and x equals to b. And here's my function f of x. Now the first condition is that fx should be continuous on closed interval a comma b, and accordingly I have made this function fx which is continuous on closed interval a comma b. And fx will also be differentiable on open interval a comma b here. Now the third point, that is fa is equal to fb. This is the main condition for the Rolle's theorem, that for x equals to a, the functional value is this much, and let us write it as f of a. And if you noticed that at x equals to b, the functional value is this much, which is equal to f of b. That means fa should be equal to f of b. Now geometrically, Rolle's theorem says that if all these three conditions are there, then there must be one point between a and b at which if I draw a tangent, then that tangent will be parallel to the x-axis. And if a tangent is parallel to the x-axis, that means slope of this tangent should be equal to 0. And it's written f dash of c, which is the slope of the tangent at point C, is 0. So this point is C here. Now let us look Lagrange's mean value theorem here. It states that if f is a real valued function such that fx is continuous on closed interval a comma b, and fx is differentiable on open interval a comma b, then by Lagrange's mean value theorem there should exist a real number c between a and b such that f dash of c equals to f of b minus f of a over b minus a. Now if you notice here, in Lagrange's mean value theorem, the point 3 is not necessary. That means the value of function at a and the value of function at b may or may not be equal. It's not necessary. Now see here, I have made a function which is continuous from a to b and which will be differentiable also. But here the value of the function at a and the value of the function at x equals to b. Now Lagrange's mean value theorem says that if these two conditions are fulfilled, then there must be a point between a and b, let us call it as c, at which if I draw a tangent, then this tangent will be parallel to the point joining this and this. So here, if you notice that this tangent and this line which is joining these 2 points are parallel. That means the slope of this tangent and the slope of this line should be equal. Now if you see here, f of b minus f of a over b minus a, it is the slope of this particular line, and f dash of c is the slope of this tangent at x equals to c. So this point is my c. So here we will be given some functions and we need to verify these theorems on that functions in a given interval. So let's start doing some questions. Question 1. Verify Rolle's theorem for the function fx equals to x square minus 4x plus 3 in closed interval 1 comma 3. So first let us check the 3 conditions that is required to apply Rolle's theorem. So at first, as you can see here, fx is a polynomial function. So since fx is a polynomial function and polynomial function is continuous, so that's why fx will be continuous in closed interval 1 comma 3. Second point, that fx should be differentiable on open interval 1 comma 3. So for that we need to differentiate the given function. So let us differentiate the given function both sides with respect to x. Then we will get f dash of x equals to 2x minus 4. Now since it's differentiable and this f dash of x, that is 2x minus 4, is defined for all values from 1 to 3. Hence it is differentiable on open interval 1 comma 3. And the third point, that f of a should be equal to f of b. So here f of 1 should be equal to f of 3. So let us check the value of f of 1 here. So let us put the value of x as 1 in the given function. Then it will be 1 square minus 4 into 1 plus 3, and this will be equal to 0. And let us check the value of f of 3. Then it will be 3 square minus 4 into 3 plus 3, and this will also be equal to 0. Therefore f of 1 is equal to f of 3. Now since the given function is satisfying all the condition that is required to apply the Rolle's theorem, so by Rolle's theorem there should exist a number between 1 comma 3 such that f dash of c will be equal to 0. Therefore we write, there exists a real number c which belongs to open interval 1 comma 3 such that f dash of c will be equal to 0. So now since we have got the value of f dash of x here, so f dash of c will be 2 of c minus 4 equals to 0. This implies 2c equals to 4, and hence the value of c is equal to 2. And if you see here, my interval was 1 and 3, and since the value of c, that is 2, lies between 1 and 3, hence the Rolle theorem is verified. Question 2. Verify Rolle's theorem for the function fx equals to sin x plus cos x in the interval 0 comma pi by 2. For that, the number 1 point, that is the given function fx is sin x plus cos x. We know that sine function and cos functions are both continuous, and the addition of two continuous function is also continuous. That means fx is continuous on closed interval 0 comma pi by 2. Second point, fx should be differentiable. For that we have to differentiate the given function. So here f dash of x will be equal to cos x, ddx of cos x is minus sin x. And since it's differentiable also, and for all x belonging from 0 to pi over 2, this cos x minus sin x is defined. That's why we can say that fx is differentiable on open interval 0 comma pi by 2. The third point, we have to check whether fa and fb are equal or not. So here we have to check f of 0, and that will be sin 0 plus cos 0, which is equal to 0 plus 1 equals to 1, and the value of f of pi over 2 will be sin pi by 2 plus cos pi by 2, which equals to 1 plus 0 equals to 1. Therefore f of 0 is equal to f of pi by 2. Hence all the three conditions are satisfied. Now according to Rolle's theorem, there must exist a real number c belonging to open interval 0 comma pi over 2 such that f dash of c equals to 0. Now since f dash of x equals to cos x minus sin x, therefore f dash of c will be equal to cos c minus sine c equals to 0. So this implies cos c is equal to sine c. Now dividing both sides by cos c, then we will have 1 equals to sine c by cos c. And we know that sine over cos is tan, so tan of c equals to 1. Now since the interval is from 0 to pi by 2, that is in the first quadrant, tan of 45 degree is 1. So here we can write tan c as tan pi over 4. That means the value of c is equal to pi over 4, and which belongs to the given interval, that is open 0 comma pi by 2, and hence the Rolle theorem is verified. Question 3. Verify Lagrange's mean value theorem for the given function in the interval 4 comma 6. So here there are only 2 points which needs to be fulfilled. Point number 1, the given function, that is x squared plus 2x plus 3, should be continuous. And since this is a polynomial function and we know that polynomial functions are always continuous, so fx is continuous on closed interval 4 comma 6. Point number 2, that this should be differentiable. For that, let us differentiate the given function, then it will be 2x plus 2. And this 2x plus 2 is also defined on any point lying between 4 and 6. That means fx is differentiable on open interval 4 comma 6. Now we can apply Lagrange's mean value theorem here. Lagrange's mean value theorem, there should be a real number c such that f dash of c will be equal to f of b, that is f of 6, minus f of a, that is f of 4, divided by b minus a, that is 6 minus 4. Now the value of f dash of c, looking here, we can write it as 2c plus 2 equals to the value of f of 6 from equation 1 is 6 square plus 2 times 6 plus 3 minus, similarly the value of f of 4 from the equation 1 will be 4 square minus 2 into 4 minus 3 whole divided by 6 minus 4 is 2. So this will be equal to 36 plus 12, here this plus 3 and minus 3 got cancelled, minus 16 minus 8 whole divided by 2. So this equals to 48 minus 24 by 2, which equals to 24 by 2, and this equals to 12. Now on the left hand side we are having 2c plus 2. That means 2c equals to 12 minus 2 is 10, and the value of c is coming 5, and this 5 lies on the given interval 4 comma 6. Hence Lagrange's mean value theorem has been verified. Question 4. Find the value of c of Lagrange's mean value theorem for the function fx equals to square root of x plus 2 in the closed interval 4 comma 6. So here we have to directly find the value of c. Fx is given as x plus 2. So differentiating both sides, we will have ddx of square root of x is 1 by 2 root x, and using chain rule ddx of x plus 2 is 1. Therefore the value of f dash x will be equal to 1 by 2 square root of x plus 2. Now by Lagrange's mean value theorem, there should exist a real number c between 4 comma 6 such that f dash of c will be equal to f of b, that is 6, minus f of a, that is 4, over 6 minus 4. Now the value of f dash of c, looking here, will be 1 by 2 root over c plus 2, which will be equal to the value of f6 and f4 will be square root of 6 plus 2 minus square root of 4 plus 2. 6 minus 4 is 2. So here 2 and 2 got cancelled. So this implies 1 over square root of c plus 2 equals to square root of 8 minus square root of 6 by 1. On cross multiplying, we will get square root of c plus 2 equals to 1 by square root of 8 can be written as 2 root 2 minus square root of 6. Now let us rationalize here, then it will be 2 root 2 plus square root of 6 divided by 2 root 2 whole square minus square root of 6 whole square. So this will be equal to 2 root 2 plus square root of 6 divided by, it will be 4 2s are 8 minus 6 equals to 2 root 2 plus root 6 by 2. So this is the value of square root of c plus 2. Now in order to get the value of c, let us square both sides, then we will have c plus 2 equals to a plus b whole square is a square plus b square plus 2ab whole divided by 4. So this implies c plus 2 equals to 8 plus 6 plus 4 root over 12 divided by 4. So this implies c plus 2 equals to 14 plus square root of 12 is 2 root 3 by 4. C plus 2 equals to, let us take out 2 common, then here it will be 7 plus 4 root 3 by 4. Then the value of c will be and now putting the value of root 3 as 1.732 here and simplifying, you will get the value of c approximately 4.964, and this is the answer for this question. Question 5. Find the point on the curve y equals to x times x minus 4 where x belongs to closed interval 0, 4 where the tangent will be parallel to the x-axis. Now here we have to note that this question is the application of Rolle's theorem, because as we discussed Rolle's theorem earlier, we said that there will be a point between a comma b at which the slope of the tangent will be 0. That means the tangent will be parallel to x-axis. So first let me show you a graph of this function. That is, our given function is y x into x minus 4, which is x square minus 4x, and let this be equation 1. And if I show you the graph of this function, then it's like this. This orange line is the graph of this function, that is y equals to x square minus 4x. Now we have to find a point between 0 to 4 at which if I draw a tangent, that tangent will be parallel to the x-axis. So obviously it is clear from the graph that the point lies somewhere here, because if I draw a tangent at this point, then that tangent will be parallel to the x-axis. So we have to find the coordinate of this point. Let this given function y be f of x. Now to apply Rolle's theorem, let us check the 3 conditions. The first condition being that the given function should be continuous on interval that is 0, 4 here. So this is continuous because this is a polynomial function, and from the graph also it is continuous. Secondly, it should be differentiable also, which will be differentiable. For that, let us differentiate the given function. Then it will be f dash of x will be equal to 2x minus 4. Now this will also be defined for all values between 0 and 4. And the third condition is that the value of f0 and the value of f4 should be equal. So my f0 will be from equation 1, 0 square minus 4 into 0, that is 0. And f4 from equation 1 will be 4 square minus 4 into 4, that is 16 minus 16 is also 0. Hence, f of 0 and f of 4 is equal. That means all the three conditions are being satisfied to apply Rolle's theorem. So now according to Rolle's theorem, there should be a point, let us say C, such that f dash of C will be equal to 0. Now, looking at the equation of f dash of x, we will write the value of f dash of C, and that will be 2c minus 4 equals to 0. Now this implies 2c equals to 4, and hence we got the value of c as 2. Now since c is a point between 0, 4, that means at x equals to 2, we will get a tangent that will be parallel to the x-axis. Therefore, at x equals to 2, the tangent to this curve will be parallel to x-axis. That means if I look at the graph, that means at x equals to 2, the tangent will be parallel to the x-axis. But since we need to find the point, so let us put the value of x equals to 2 in the equation 1 to get the value of y. Then my y will be equal to 2 square minus 4 into 2, and from which I'll get the value of y as 4 minus 8, that is minus 4. Therefore, the required point is 2 comma minus 4. And in the graph also it's clear that at this point, that is 2 comma minus 4, if I draw a tangent, then that tangent will be parallel to the x-axis. So here's the end of the question and end of this video, and also the end of this entire topic, that is application of derivatives. So stay tuned and leave a like and do comment and share this channel with your friends. Thank you and keep learning. Bye bye.